Okay, so we're going to continue on with the focus of a parabola. I'm going to focus again on the focus. Never gets old. All right, so before we do that, I want you to think about what is the relationship between the vertex and the focus, what's the relationship between the vertex and the directrix, and is the vertex of a parabola always at the origin? So pause the video, just kind of answer those questions, and we'll unpause and discuss. Okay, so I said, and hopefully you said something along these lines, the relationship between the vertex and the focus is that they are p apart, and they are on the axis of symmetry. So they're both on the same axis of symmetry. The relationship between the vertex and the directrix, they are also p apart. I didn't say anything about the axis of symmetry. There is a relationship. Remember, the directrix is perpendicular to the axis of symmetry, but that's not totally relating to the vertex. I mean, it does, but so they're p apart. And remember, this isn't what the question is asking, but the focus is always inside of the parabola and the directrix is outside of the parabola. Another way to say that is the vertex is halfway between the focus and the directrix. Is the vertex of a parabola always at the origin? No, it is not. So here is our now more generic, broader relationship between a focus and a directrix of a parabola. Here is the parabola in vertex form. Remember, instead of 1 over 4p, we usually write a. So a is 1 over 4p. The focus then is going to be the point h comma k plus p, and the directrix is going to be the equation y equals k minus p. And remember, p could be negative, so when I say k plus p, it could actually be down. Okay, another thing to kind of emphasize, and I've talked about this before with other concepts, this is not stuff necessarily to memorize. If you just understand the relationship between a vertex and a focus and the vertex and the directrix, it's really easy to find this stuff and you don't have to memorize these little equations. So let's go ahead and see an example. Great. Write an equation of a parabola with a vertex at -1, 4 and a focus at -1, 2. So what I would recommend doing, this is how I actually do these problems. It's a recommendation because it's what I prefer. So I would just do a rough sketch of this. And if I do a rough sketch of it, it will give me enough information to help me write the equation of the parabola if I need to. And in this case, I could probably actually get away without even doing a rough sketch, but I'm going to do a rough sketch anyway. So I'm going to plot this point, -1, 4, and then I'm going to plot this point, -1, 2. So I know those are both, so let's see, -1, 1, 2, 3, 4. So here's -1, 4. Here's -1, 2. Since this is the focus, color that in green, and the red is the vertex, I know that the parabola has to open down. I know this distance here has to be p. That distance is 2, so I know p is -2 since it's opening down. So my equation then, I know a equals 1 over 4 times -2, so -1/8. I know the vertex, so I know the equation of the parabola is y equals -1/8 times x plus 1 squared plus 4, because we knew the vertex. That's it. But see what I mean, how I didn't use this equation? We could have, and it's essentially the same thing, but just drawing the picture I think is a better visual, easier way to do it. I don't know, just my opinion. So let's try another one. A parabola has a focus of 2, -6 and a directrix of y equals 6. So again, I'm going to go with my preferred method of draw a picture. So first, let's see, 2, -6. It's going to go right 2, down 6. So that's going to be in the 4th quadrant, and y equals 6 is going to be a horizontal line above the x-axis. So let's do this. I'm going to say 1, 2, 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. So that's my directrix. And this is my focus. So where does the vertex have to be? Well, the vertex has to be halfway in between them, and it has to be on the axis of symmetry. So since this distance here is 6, and this distance here is also 6, I know that the vertex has to be right here. Since the focus is below, I know that the parabola has to open down. So this is why, again, drawing a picture just kind of helps. So that's at 2, 0, and I know P is -6, so A is 1 over 4 times -6, which is -1 over 24. So my equation is going to be y equals -1 over 24 times x minus 2 squared. That's it. See? Not bad. Alright, identify the vertex, the focus, the directrix, and the axis of symmetry. I want you to try to do this. Pause the video, unpause when you're ready to discuss. Okay, so hopefully you got the vertex is 0, 0, axis of symmetry is x equals 0, focus is 0, 3, directrix is y equals -3. How did I get this information? Great question, glad you asked. So, if I first look at the function, I can see that nothing is added or subtracted inside the function, which is inside the squared part, and nothing is added or subtracted outside the squared part, so that's how I know the vertex is at 0, 0. The axis of symmetry then is x equals 0, because that's the h-coordinate of the vertex. How did I get the focus and directrix? Good, we're getting there. So I take my a value, 1 over 12, and I set it equal to 1 over 4p, so I can find p. First I multiplied both sides by 4p. That made this side 1, and this became 4p over 12. The 4 and the 12 reduced to p over 3. Multiply both sides by 3, and I get p equals 3. So I know my vertex is at 0, 0, and since a was positive, the focus has to be above that a distance of p, and the directrix has to be below that a distance of p. So that's how I know my focus is at 0, 3, and my directrix is y equals -3. Alright, now I want you to try this one. And again, if you're stuck on any parts of this, you should still be able to do some of it. Like, you should be able to identify the vertex at this point and graph the vertex. So go ahead and do as much as you can. Hopefully you can get everything, but try this on your own. Pause the video, unpause when you're ready to check. Okay, so this is a good example of sometimes it's actually a little bit difficult to graph the focus and the directrix, depending on the numbers we're dealing with. But we should still be able to graph the function and the vertex. So the vertex is -2, -1, and I can get that because this is my vertex form. So I'm going to plot that. I know the a value is positive, so this is going to open up. My axis of symmetry then has to be x equals -2. So then I take, to find the focus and the directrix, I take my a value, so that's 8, and I set it equal to 1 over 4p. Multiply both sides by 4p, and this becomes 32p equals 1. Divide by 32, so p is 1 over 32, so it's really, really small. So I'm not even going to try to plot 1/32 of a unit on this graph. But I can still label where the focus should be. So the focus is at -2, because it's the same coordinate as the vertex, comma, -1 plus 1/32, because it's going to go up. If I use my calculator or understand adding fractions, that's -31 over 32. The directrix is going to be from the vertex but down, so if this is at -1, it's going to be -1 minus 1/32, which is -33 30-seconds. So it's y equals -33 30-seconds. Okay, let's try one more. Again, I want to have you try and do this. My hint is first, let's rewrite this. So it's y equals -1/4 x squared. That's going to make it easier for us to find the information that we need. So pause the video, identify the focus, the directrix, the axis of symmetry, and graph the parabola. In doing that, you should probably also find the vertex. Okay, pause the video. Okay, so hopefully we got a parabola that opens down like this. The vertex was at 0, 0. And again, I know that because nothing's added or subtracted inside the function or outside of the function. Therefore, the axis of symmetry is at x equals 0. I set my a value, which is -1 over 4, equal to 1 over 4p. Multiply both sides by 4p, -4p over 4. The 4's cancel, and I divide by -1, so p is -1. Since it's negative, I know that the parabola is opening down. So from the vertex, I'm going to go down a distance of p. So 0, -1 is the focus. And from the vertex, I'm going to go up a distance of p, and that's going to be y equals 1 is my directrix. Nice work. I'm proud of you.